A black hole is the ultimate prison. Its gravity is so absolute that light itself, the fastest thing in existence, can't break free. Whatever falls in is gone forever. That's the story we all know. Except, it isn't quite true, because one of the most brilliant minds in physics proved that black holes are not perfectly black. Something does escape. They glow, ever so faintly. They leak, and given enough time, they can disappear entirely. So the real question isn't whether a black hole traps everything. It's this: what, exactly, can slip past the universe's most inescapable trap? The answer is stranger than the prison itself. On the face of it, the answer seems obvious. Nothing escapes. End of story. But the truth is far richer, and it sits right at the crossroads of Einstein's gravity and the quantum world. In the next few minutes, we'll separate myth from reality. We'll see what genuinely can't escape, what can escape from surprisingly close to the edge, and the bombshell discovery that black holes slowly evaporate into nothing. We'll even tackle the deepest puzzle of all: whether the information about everything that ever fell in is truly lost, or quietly finds its way back out. Let's start with the part that's actually true. Let's give the classic answer its due, because for one specific region it's completely correct. To escape any object's gravity, you need to reach its escape velocity, the speed required to break free. For Earth, that's about 25,000 miles per hour. Pile on more mass in a smaller space, and that speed climbs. At the event horizon of a black hole, its boundary, its point of no return, the escape velocity reaches the speed of light. And since nothing can travel faster than light, nothing that crosses that line can ever come back. Not a spaceship, not a signal, not light itself. So from inside the event horizon, the prison is genuinely perfect. But notice the careful wording: inside. Because just outside that line, the story changes completely. Here's the first surprise. Some of the brightest, most violent phenomena in the universe come from material right next to black holes. As gas and dust spiral inward, they pile up into a superheated disk, glowing fiercely as friction heats them to millions of degrees. And many black holes launch staggering jets, beams of matter blasted from their poles at nearly the speed of light, reaching across entire galaxies. None of this comes from inside the horizon. It all escapes from the chaotic region just outside it, where matter is flung away before it ever crosses the point of no return. So the area around a black hole isn't a quiet void. It's the most powerful engine in the cosmos. But that's matter dodging the trap. The real shock is something escaping from the boundary itself. In 1974, Stephen Hawking dropped a bombshell that changed physics. By combining gravity with quantum mechanics, he showed that black holes aren't perfectly black after all. They emit a faint stream of particles, a whisper of radiation, now named in his honor, Hawking radiation. This was revolutionary, because it meant energy is genuinely leaving the black hole. The prison has a slow, almost imperceptible leak. For an ordinary black hole, this glow is mind-bogglingly faint, far colder than the depths of space, far too dim to ever detect directly with today's instruments. But it isn't zero, and once you accept that a black hole can lose energy, an extraordinary consequence follows. One Hawking realized immediately. So how does a black hole emit anything if nothing escapes from inside? The key is that Hawking radiation doesn't come from within the horizon, created right at its edge, where the quantum world meets extreme gravity. Empty space, it turns out, is never truly empty. At the quantum level, it constantly churns with fleeting bursts of energy. Near the razor's edge of a black hole, this restless vacuum gets disrupted by the intense gravity in such a way that the black hole steadily radiates energy into the space around it. The simplest popular picture imagines pairs of particles forming at the brink, one slipping in, one escaping out. The real mechanism is subtler, but the upshot is the same, and it's profound. The black hole pays for that escaping energy with its own mass, which means it's shrinking. Here's where it becomes genuinely astonishing. Because a black hole loses a sliver of mass every time it radiates, it is slowly evaporating. Drop by drop, over time it shrinks. And there's a twist. The smaller a black hole gets, the hotter and faster it radiates, so the process accelerates toward the very end, finishing in a final burst. Given long enough, a black hole doesn't last forever. It fades away entirely. Now, long enough here is almost beyond comprehension. Vastly, unfathomably longer than the current age of the universe for any large black hole. These are timescales that make the lifetime of stars look like a blink. But the principle stands, and it's staggering. The most inescapable objects in existence are, themselves, not permanent. Everything they swallowed eventually returns to the cosmos as radiation, which raises a haunting question. If everything that falls in eventually leaves as radiation, what happens to the information? The unique details of everything that was swallowed? Drop a book, a planet, a person into a black hole, and the radiation that trickles out seems utterly featureless, carrying no trace of what went in. But quantum physics insists information can never be truly destroyed. That clash is the famous black hole information paradox, and it's tormented physicists for decades. The exciting news: in recent years, the tide has turned. Since a major breakthrough around 2019, using ideas with names like entanglement islands, the leading view is now that information is not destroyed. It does, somehow, escape encoded in the radiation. The catch? Physicists still can't fully explain the precise mechanism, and a complete answer likely awaits a finished theory of quantum gravity. So the paradox isn't entirely solved, but the smart money now says nothing is lost forever. There's one more thing that escapes black holes, and unlike Hawking radiation, we've actually detected it. When two black holes collide and merge, they violently shake the fabric of space-time, sending out ripples called gravitational waves. These ripples race outward at the speed of light, carrying off enormous amounts of energy, and they pass right through everything in their path. In 2015, detectors on Earth caught these waves for the very first time, from a merger that happened over 1 billion light-years away. So while no light escaped those black holes, a signal absolutely did. A tremor in space-time itself, telling us they existed, how heavy they were, and how they spun. The most silent objects in the universe sent us a message we could hear. So can anything escape a black hole? The honest answer is a beautiful yes, more than you'd think. Matter escapes from just outside the edge in blazing jets. Energy escapes through the faint glow of Hawking radiation, slowly draining these giants to nothing. Information, it now seems, finds its way out too. And the echo of black holes colliding reaches us, as ripples we can detect from across the universe. What's remarkable is that we worked all of this out without ever touching one. By following the physics to its logical, astonishing conclusions. The universe's perfect prison, it turns out, has more exits than anyone imagined. So let's bring it together. From inside the event horizon, nothing escapes. That part is genuinely true. But just outside, matter is flung away in brilliant jets. The horizon itself leaks Hawking radiation, meaning black holes slowly evaporate and can one day vanish completely. The information about what fell in is now thought to escape with that radiation, though the full mechanism remains a frontier, and the collisions of black holes send gravitational waves rippling across the cosmos straight to our detectors. A black hole is the most extreme trap in nature, but nothing escapes turns out to be one of the great myths of physics. If this rewired what you thought you knew about black holes, do me a quick favor. Hit that like button. It really does help these ideas reach more curious minds. Share it with the friend who's convinced nothing escapes a black hole. And if you want to keep exploring the universe's most mind-bending secrets with us, subscribe and ring the bell so you never miss what comes next. The cosmos is full of exits we're only just beginning to find, and there's so much more to uncover. Until next time, keep looking up.